Welcome back to SMS Foundation. We are going to continue with our question 6. This is question 6b, which says find the projection of the vector A on the vector B if A equal to 5i minus j and B equal to 6i plus 8j. Here comes the solution. Here comes the solution. Now, we are asked to find the projection of vector A on vector B. We have a standard formula for that. So, projection, let us write the given vector first. Let's list out the given vector. Vector A equal to 5i minus j, and vector B equal to 6i plus 8j. Now, in order to find the projection of A on B, we are going to take the dot product of A and the unit vector of this. We can represent that like this. Projection of A on B equal to A dot unit vector of B. So we say where B equal to B bar, where bar B equal to unit vector in the direction of B. Now, our next line of action is to find the unit vector in the direction of B. Unit vector in the direction of B is given as B unit vector equal to vector B all over modulus of vector B. Now, so our unit vector in the direction of B is given as B all over modulus of vector B. Now, we have to find the modulus of vector B, which is the only major issue here. There's no problem with this, but this is the only major problem that we have here. So, we have a standard formula for finding modulus of a vector. So, let's recall the formula. Recall, if vector P equal to xi plus yj, then modulus of vector P will be given as square root of x squared plus y squared. So this is the formula for finding the modulus of any vector P, which is equal to xi plus yj. Now, we can always apply this to find the modulus of vector B. Let's apply that. Therefore, modulus of vector B is given as square root of. Now, I'll compare this vector and this. We see that if we compare this, our x is going to be 6 and our y is going to be 8. So let's substitute. That will give me 6 squared plus 8 squared. That means modulus of vector B will be equal to square root of 36 plus 64, which is the same thing as square root of 100. Now, thank God that 100 is a perfect square. That means modulus of vector B equal to square root of 100, which is 10. Now, we now come back to this, which is the unit vector of B is given as vector B all over modulus of vector B. And what is my vector B from here? That's 6i plus 8j all over modulus of B, which is 10. And I can go on distributing the denominator for both the terms on top. That will give me 6i all over 10 plus 8j all over 10. Now I can reduce this to the lowest term. So I will have unit vector of B equal to 2 here 3i all over 5 plus 2 here 4 and 2 here 5. That will be 4j over 5. That is the unit vector in the direction of B. Now, I can now give this. So that means I can still rewrite this as 1 over 5 bracket 3i plus 4j. So I can rewrite that since the denominator is common. So we can always leave it like that. So we now come back to the formula for projection of vector A and B, which is A dot unit vector of B. So this is the dot product. We are taking the dot product of the two. So projection will be equal to A dot unit vector of B. So what is my vector A? I have my vector A here, which is 5I minus j dot unit vector, which is 1 all over 5 bracket 3I plus 4j. Now, since 1 over 5 is a constant, it will not be affected by the dot product. I can bring it out. Let's bring 1 over 5 out. Then we have 5I minus j dot 3I plus 4j. Now, over here, our dot product is going to be, dot product is very simple. Just say this times this plus this times this. That is the coefficients attached to the letters I and J. So we are just going to multiply. So that will give me 1 all over 5 brackets 5 times 3 plus minus 1 times 4. So that will give me, so we have a way of deriving that, but we don't have time to derive that now. That will give me 1 over 5 brackets 5 times 3, that will give me 15. Plus times minus, that will give me minus 1 times 4, that will be 4. So this is what I will simplify in order to get the projection. So 15 minus 4 is going to give me, okay, 1 over 5 bracket 15 minus 4. 15 minus 4 is going to be 11. That's 11. So I can now put the two together to have 11 all over 5. That's 1 times 11. That will give me 11 over 5. Therefore, the projection of vector A on B is going to be 11 over 5. Now, note, this kind of projection is scalar projection. We have two kinds of projection. We can have vector projection. Since the question does not state it, so always find the scalar projection anytime the question does not state it. Thank you.